Well, my dad was my hero. We were we He was a deacon in our church, and we were in Sunday school every morning. And I guess from his military experience, he was very structured. We made sure that when we went to church, our shoes was shined, and so the night before we'd be shining shoes. So just the whole process was, that was his thing. He gave me my first lesson in electronics, and he had spent time in the military, and he knew some basic things about electricity, and he communicated that to me. And whenever he would be repairing the car or doing some project around the house, I was always there watching just out of curiosity.
Welcome to another episode of Everything Intellectual Property. Today, we have a very special guest with us. This gentleman has over 100 patents, including arguably his most famous patent, the patent on a super soaker. Please help me welcome the founder of Johnson Research and Development, Lonnie Johnson. How is it going, Mr. Johnson?
Going fine. How you doing, Dave? Great meeting you.
Yeah, nice meeting you as well. And I know we're talking offline and just kind of excited to do this one and kind of really wanted to kind of get right into it. I know you said you have to get to lunch here, so the lunch is important. So I don't want to keep you from, a nice meal. But just kind of really starting out at the beginning, I was kind of preparing for this interview and kind of reading through your story and just wanted to, from the parents' perspective, get your I guess explanation on kind of your parents. And it seems like your father and my father, he kind of passed away when I was younger, but he had businesses and things like that, although he didn't kind of make it through middle school. And it seems like kind of your father, he was still a very smart man, even though maybe he didn't kind of finish high school. And it seems like you kind of learned a lot from him. So can you maybe kind of talk a little bit about kind of the parenting and growing up?
Well, my dad was my hero. He was a deacon in our church, and we were in Sunday school every morning. And I guess from his military experience, he was very structured. We made sure that when we went to church, our shoes was shined, and so the night before we'd be shining shoes. So just the whole process was, that was his thing. He gave me my first lesson in electronics, and he had spent time in the military, and he knew some basic things about electricity, and he communicated that to me. And whenever he would be repairing the car or doing some project around the house, I was always there watching just out of curiosity, and he was my hero.
Nice. No, that's amazing. So did he maybe, because again, later on when you started to, the bachelor's in mechanical engineering as well as master's in nuclear engineering, was that something that he maybe kind of said to go into, or I know you nicknaming?
He was always supportive, and pretty much let us find our own way, because he that was something that we would have to do, and I think that was probably his strength, was being more hands off, in fact, and just of course, when we needed correcting, he was there with some pretty stern corrective measures. I will say that. Oh, that's one of the things I think. But growing up, the closest thing I can think of that if anyone in my generation, there was a series called The Little Rascals. Now they made a movie out of it later on, but it did not capture the essence of what the Little Rascals were. They were a bunch of kids, friends, who always had some kind of project going on, and they would be one project after another, always into something in the neighborhood, and they just and my childhood was pretty much like that. We could roam all over the city, and we played touch ball and we climbed trees. We rode bicycles. We played in the street, stick ball and things like that. I mean, it was just, and I would have my own projects that I would be working on, go-kart or whatever it was, and I'd have my little posse with me, and they were always curious about what I was doing, and it was just like that. And they would help when they could, so we would build go-karts and push each other around, and We had, I mean, that's what it was like.
No, nice, nice. And you must definitely rubbed off on the neighborhood in a positive way to get the nickname. I think was the professor that they called you growing up.
They used to call me the professor. Yeah.
Yeah, you must definitely was smart to get that name as a kid growing up. So then at what point did you decide as you were kind of going into college to say, okay, I'm gonna study engineering? Because I think a lot of us growing up, we were tinkers, tinker with different things, build different things. However, when it's time to get maybe a formal education, we do something completely different or don't. It seems like not a lot of people go into like the engineering field, whereas you said, okay, I'm gonna kind of continue on with this kind of creativity and kind of problem solving ability to go to, get the master's. I mean, the mechanical engineering degree before getting your master's in nuclear engineering.
Right. Yeah. No, I wanted to be an engineer for even before I knew what the word engineer, that it was called engineer. I was always tinkering, like I said, building things. And even as a small kid, was curious about how things work. So I was always taking things apart, looking inside, took my siblings' toys apart, my toys apart. Sometimes made something different with the parts, and other times just put it back together the way it was. And just the skill of taking something apart, complicated, and then being able to put it back together in itself was a skill that developed naturally out of my curiosity. The thing that I guess kind of sealed the deal was my high school science project. I used to build rockets and things, even got to the point of mixing rocket fuel. But my high school science project took me about a year to build. I had a fully remote control robot that I built, and literally from going to the library, problem solving, just kind of feeling my way, making do with what was available to me. I guess my major tools were a hacksaw, screwdriver, pair of pliers. Every now and then, I had a neighbor who would loan me a drill that I could use to drill a hole. But I literally built a robot with those kind of tools,
Wow.
and he was fully remote control, fully programmable. I used back then. This was back in the '60s, so nobody really had robots back then. They didn't exist. The my siblings had gotten a walkie-talkie for a Christmas present, so I used that to transmit signals to the robot. Another sibling had a tape recorder, and so I used the tape recorder as a memory, so I could transmit signals and record the signals and rewind the tape recorder, and the robot could obey the signals on the tape. So I literally had a way of programming it. It was about 3 feet tall, so it was big size.
Very sound.
And he won first place at the University of Alabama in '68. And this was just a few years after Governor Wallace had stood in the door and said that no student would attend this university. So that was a major personal moral victory. A recruiter from Tuskegee came down to my high school and offered us a scholarship in mathematics at Tuskegee. And so my first year in college was actually as a math student, as a math major on that scholarship. But I don't know if I got through a complete semester before changing my major to engineering, because I knew that's where I wanted to go.
So was it like the plan all along, and maybe you just wanted to get the scholarship money, or was it?
I just wanted to get it. I wanted to get into college, and that was the path to get there.
Got you. And they didn't. It wasn't a big deal. I know sometimes it kind of be a little bit more difficult to switch your major in college, but it wasn't that big of a deal at Tuskegee to switch it from mathematics to.
Yeah, it wasn't. Well, I didn't appreciate the impact, the fact that scholarship had come out of the School of Mathematics allocation.
Yeah.
So when I did change, the head of the math department did look at me, and the guy who came down and recruited me, he was kind of not happy about it. But what was interesting about that, after the first test, and I did well I was taking math classes. And when I did well on this test, he looked at me just holding me to change. He became very supportive and very positive, and felt that I would have a great career. He still thought that mathematicians were more intellectually stimulating than engineers. But to me, math was kind of engineering was more exciting, I just say.
Oh, yeah, and I definitely have my mechanical engineering degree as well. I definitely think that engineering is, math is cool and it's numbers, but just being able to apply it to something, that it seemed like that part of it.
Yeah,
Uh,
yeah. I mean, there was a lot of theoretical math when you get to
yeah,
even in engineering. But at the same time, some of the advanced mathematics tools that they taught engineers was very powerful math. But at the same time, it's a lot of memorizing steps to do the analysis, Bessel
gotcha.
functions, and things like that. Was very Laplace transforms.
Yeah,
Just very sophisticated mathematical tools that were very powerful, but they weren't like making things work. It wasn't like
right.
building stuff and
Yeah.
machines and things that really turned me on. But so anyway, each to each his own.
Right. No, for sure. And you're absolutely right about that. You even in engineering, I know differential equations. Y'all remember the Laplace transform, and you get to these high level kind of theoretical things, but you're not applying them to anywhere. But then for you to say have a mechanical engineering degree, then to say, okay, I want to do nuclear engineering as it relates to the masters. Was that something I know you talked about kind of building rockets and things like that? Was that always
Yeah.
an interest, or did that just kind of
No,
start?
no, long-term interest. One of my professors, who in fact Tuskegee had a nuclear engineering program back then, and one of my professors actually encouraged me to go on to grad school and major in nuclear engineering. I had gone through ROTC.
Yeah.
I was scheduled for flight training as a navigator. I had gone to ROTC summer camp and did a check ride in a jet fighter, which was exciting in itself. But at the same time, I decided, no, this is not for me. It was like we were doing dives and rolls and pulling G's and getting thrown back in the seat. It's a real thrill ride, but I don't particularly like Ferris wheels, but no.
Oh, that's funny. So then with you ultimately went into the Air Force and started working after I'm
Right.
assuming that was
So
after maybe.
so I got an educational delay to work on my master's degree.
Got
So
you.
that's what
Okay, now
I
that
did.
makes sense.
And so then I went on active duty. My first job was at Oak Ridge National Laboratory. It's about 6 months because I graduated early, and so my you know, so I took a job at Oak Ridge National Lab and waiting to be called to active duty in the Air Force. And my first job assignment rather was at the what was in the Air Force Weapons Laboratory, Kirkland Air Force Base in Albuquerque.
Okay.
And there I was a nuclear safety officer. We were looking at U.S. space launches that use nuclear power sources and looking for, doing failure analysis, second guessing NASA, things that, if there was an accident. The whole idea was that, a mission like Voyager, which is what we were working on at the time, um, uses a nuclear power source. And we were looking to see if there was an accident or something like that was to happen. Would the nuclear material be released to the biosphere, which would cause some environmental issues? So we were basically doing failure analysis and to try and make sure we minimize the risk of the space launch by addressing any problems that we identified. But I
Gotcha.
got I did well with that to the point where NASA offered me a job at the Jet Propulsion Laboratory. So I left the Air Force and went to JPL.
Yeah.
Because I was curious, I was thinking, geez, I'm doing second guess analysis, looking for things to go wrong, failure
Yeah.
analysis and so forth. But I wanted to be on the other side of the fence. I wanted to design the spacecraft. I felt like, you if the launch vehicle people and NASA and the spacecraft design people did their job correctly, no one would care about the second guess analysis or worst case failure analysis. So I wanted to be able to see how it was done because at that time it's just a matter of curiosity. How do they build a spacecraft, launch it, and then have it travel for years, getting to a planet? You hear about things going wrong, and then all of a sudden this mission whatever the failure was, they managed to recover from it. You can go into orbit years later or around the planet and start taking data. And it was just so fascinating. I just wanted to know how it was done. And so I went to JPL to learn.
No, and it seems like, again, not only did you learn, but you was able to work on some pretty important things. Kind of reading about the planetary spacecraft going to Mars, Jupiter, Saturn. I mean, these seems, at least kind of when I'm kind of reading these things, it's like, wow, these are like mind-boggling things on one end. But like, okay, you did this. Do you ever kind of sit back and kind of think on all the amazing things that you did, especially with regard to NASA? And it seems like you were able to work on some cool things.
Yeah, I enjoyed that. Now, I mean, it was very rewarding. I ended up on the Galileo mission as a power systems engineer. I was responsible for integrating the power system on the spacecraft, making sure because the way that works, those systems are built by various companies and even some universities responsible for developing the science instruments that would go on the spacecraft. So all the parts were being built literally globally. Germany, I think, was the propulsion system. Doing the propulsion system, it was coming from Germany. And so the idea was that everybody was making all these parts to a puzzle. And when one day there was a delivery date where all of those components would have to be delivered to the Jet Propulsion Laboratory, and then you assemble the spacecraft. Yeah. So all the connectors on the pin had to be in the right place and the right voltages and the right signals. All the bolts and screws had to be in the right place, and even the balance of the spacecraft, because Galileo was a spinner, so it's like a spinning top. It had to be dynamically balanced. So all the weights and distribution of everything. The attitude control system, science instruments were in one location. The RTG is out on the moon, So, but it all came together and was delivered on a delivery date. And you literally bolt everything together, plug all the connections together, and you turn it on. The computer fires up, and that's the ideal scenario. But all of that design work has to be done in that kind of detail, so that because it's a one of a kind thing. It's not a ongoing production. And back then, a lot of the design tools that we have today, things are a lot more straightforward. But back then, we did a lot of little cut and pasting of documents where we used scissors. we used a lot of whiteout. The change control process was literally documents that would circulate to different offices, and people would sign off on a design change.
So with all that being said, because like you said, back when you were working on this stuff, 60s, 70s, it was a lot different technology, especially with regards to the technology compared to now. How do you kind of look at maybe what Elon Musk is doing with something like SpaceX, where it seems like he's kind of maybe launching something instead of orbit every other week?
There are two sides to that. A lot of that work, what Elon Musk is doing is literally built on work that NASA did back in that time frame, 70s and 80s, and even 90s, during the time when I was there. The rocket engines, the engines that those vehicles use are engines that were developed by NASA. So it really is just building on a foundation that was created, and the technology was mature enough that transitioning it to, commercial contractors.
Gotcha.
That was more or less a long-term strategy. So yes, it's challenging, but at the same time, there's a strong foundation that all of that
right.
is built
yeah,
on.
okay. And that makes perfect sense. The fact that he's not starting from scratch with this stuff, but really kind of building on what you all in NASA did. I'm kind of.
I mean, those engines, developing powerful rocket engines, that goes all the way back well into the 60s when even the Saturn V rocket that took man to the moon, it was, I think even the shuttle rocket engines, the shuttle engines, I think, I'm trying to remember the numbers, 1.1 million pounds of fuel, like 3 to 5 million pounds of thrust, from the engines. I mean, these were very, very powerful rockets. So there was a strong foundation to build.
Sounds like so.
Even the nozzles that you see on the bottom of those engines, the fact that they don't burn up because the fuel circulates through coils on the nozzle to cool the nozzle and keep the temperature down before it goes into the engine and actually gets burnt. So there's those kind of things, sophisticated solutions, they were developed over time. So he has a lot to.
Yeah.
It's nice. It's nice to have someone looked up to as as having done some significant things in space. But he has a strong foundation that he built on. That he was just, I think, I hesitate to say, fortunate that he had the financial resources and the government relationships to start the company and get the contracts and so forth. So you have to acknowledge that and give him his kudos for successfully pulling it all together.
No, and you bring up a very good point in terms of really just having the right timing of it all, of having the money, having the relationships with the government, then having what NASA had did in the 70s and 80s and kind of putting all this together and kind of taking it from there. It seems like it was a lot can go wrong, and it seems like just the start.
I mean, every invention. I mean, the state of technology it builds on itself. I mean, we are where we are because of all the work that others have done before us.
Yeah.
So,
and I tell people as a patent attorney, I tell people that, hey, man, it's not too many things that you're making new from scratch or a big, just a big breakthrough. A lot of it is just kind of small incremental improvements upon something that had been done before.
Yeah, that's the way technology is. It evolves.
Yep.
I mean, every now and then you have a breakthrough like a super soaker where you just do a quantum step. And so those are the kind of things that I try to focus on. I want to change the games. So the technology, energy technology, for example, that I'm working on now, I started working on solid state batteries long before other people realized that would be the next thing beyond lithium ion batteries. So now we've got a solid state battery that is a true solid state battery. And as best I can tell, we're probably one of only two, if three companies, maybe if not just two companies, that have a battery that you can say is really a true solid state battery. Other companies have hybrids. They have a solid electrolyte with liquid electrolyte in the cathode. People want to use lithium metal as an anode material because you get higher energy density, but those are challenges that people have struggled with. We have an approach here that is working, and the significance of that is that instead of an electric vehicle doing 300, 350 miles on a charge, think about 600 to 700 miles on a charge. So it's a game changer in that regard. And we are where we are because of having the vision and starting early to try and solve the many electrochemical problems and material problems that are needed. And it really comes down to that. There's engineering and then there's material science, I guess is one way to describe it, because materials make engineering possible. I mean, it makes the most sophisticated stuff that you do possible. So being able to develop the materials that makes a solid state battery possible is what we've focused on and have been successful at.
Nice.
And so the other thing I'm working on, I've invented a new type of engine that converts heat into electricity more efficiently than existing engines, and it doesn't have any moving mechanical components. And so we're focusing on low grade heat because it's all solid state and it has high efficiency. Yep. We are looking at geothermal energy, low temperature geothermal that you can access almost anywhere with a relatively shallow well, 1 to 2 miles deep. Our major investor there is an oil and gas company that was looking for a technology that could convert low temperature heat into electricity, because what they were saying in the beginning is that, if we could do that, then just 20% of the abandoned oil wells where they've gotten all the oil out and they capped the well, there's geothermal heat down there at about 100 to 150 degrees centigrade. And if you can convert that heat to power, then just 20% of the abandoned oil wells could supply all the U.S. power needs. And I'm like, really? Okay, I'll be there. So we've got an engine. We demonstrated it works. They made a major investment. And so we're moving that technology forward at this time. So my focus has been on changing the game as opposed to incremental improvements.
I got you. And that's interesting.
But I could afford to do that because I had income from Super Soaker.
Yep. Oh, for sure.
To support my habits.
Your expensive habits. So, but because I do want to talk a little bit more before I get you up out of here, Super Soaker. But then I guess before doing that, what made you say was part of what made what made you go into this field? Because you were thinking big as opposed to, hey, I want not just these incremental improvements, but I kind of really want something a lot more bigger, and this is the space.
Yeah, well, I tell people that Super Soaker spoiled me. Before Super Soaker, they used little small pistol finger actuated water guns, and we changed the game and made huge success. The other thing is, looking at things and I guess if I could say there's a theme over my career or life, it's been challenging myself. So building the robot in high school was a challenge. Can I do this? Can I pull it off? Can I actually build a big robot? And I tell people that I used to watch robots on TV, Lost in Space, and then Monsters from the Ed.
Yeah.
But those robots had people inside, but nobody told me that they had people inside. So I didn't know any better than to try to build my own robot. So it became success. But it really is about challenging yourself, taking on a tough problem. And I decided, what could be more challenging than actually addressing the environmental challenges and climate change and
Okay.
dependence on CO2 and so forth. And I figure if you can solve the problem or come up with a solution that at least takes a dent out of the problem,
Yep.
then there would be a need there, and so the economic success would come with that. So it's not like coming up with an invention and then trying to convince people that it's a good thing. Addressing a need really puts the odds of success in your favor. But at the same time, if it's a big need, then you know that there are a lot of other people working on it as well, and so it becomes very competitive. But we've done well. I mean, in that regard, it's been, like I said, a challenge, a long-term challenge in working on the environmental problems that we're facing. But having a way of producing renewable energy and then having a way of storing it are the two key components.
Okay, no, and that makes sense. I guess with regard to the Super Soaker, what would you talked about? Hey, just wanting to have a big breakthrough. When did you know that? Hey, this is something special. This is really resonating with kind of the people because it
was interesting.
that out.
I got the idea for a high-powered water gun, but I had to design it, build it, and so it was several weeks. In fact, it was months because when I got the idea, I was still at JPL, and it was I would tinker around in the evenings, but I didn't try to actually build a gun until I went back into the Air Force, moved to Omaha, Nebraska, got my house settled in and everything, set up my shop. That's when I started working on the gun. I had to design it, build all the components, make all the components. I had a little machine shop, so I literally machined all the components out of plastic. Some of them were metal components, but got the Coke bottle and PVC pipe and some plexiglass that and making valves and using springs and little cut pieces of rubber out of inner tube rubber, literally to make the little flappers for tank valves, and just literally making all the components and then gluing them all together. So including a little pump on it. And so it wasn't until I actually built a gun, which took a few weeks, and then pumped it up, that I actually saw how it would work for the first time. But I put all of the engineering skill into making sure it was going to be a very powerful water gun. So that was the intent. And first time I shot it, I was very satisfied with the results. So and I would, my kids would play with it. I would even take it to some of the office functions. We would have picnics and things like that with my coworkers, and it was always a hit. So I knew it would be successful. I did not anticipate that it would be a top selling toy globally.
Yeah.
But I knew I would make money, and the idea was just to make enough money to support myself, so I can become a independent full-time inventor.
No, and you definitely did that. I guess, yeah, just kind of being respectful of your time. I do maybe have just one last question for you. How important, and again, the whole theme of kind of my show and kind of me when I bring on guests is intellectual property. As a patent attorney and kind of knowing the importance of trademarks, I think even with the Super Soaker going, it wasn't called Super Soaker. It was something else at first, and then you guys had to kind of rebrand it and it kind of
right. So that was because someone claimed the name. They had a package that initially it was Drencher, and this guy had a toy water gun that he had he called it something else, but Total Drencher or something is one of the taglines that he put in. So he said, I have Drencher on my package, so, Drencher, you're going to have to pay me royalties. So we changed the name to Super Soaker. But, in terms of intellectual property, so the patent licenses on the water guns, and we did a whole series of them, different size, different working mechanisms and everything in different designs. And that was a contract where the company made improvements. I made improvements, all fell under the contract, which was a really team
Nice.
effort, the right way to do it. And that became very successful. But I did not own the name Super Soaker. If I had understood business, I would have known that the brand was really important as well. We had jointly came up with that name, but at the same time, I didn't say I want to get royalties on the brand as well. So when Super Soaker became successful, they started putting other product under the brand name Super Soaker, even though they weren't water guns. They didn't use my technology and so forth. And so, okay. So along the way, I decided I wanted to be king of all toy guns. I just began challenging myself. Can I do that? The other guns that were out there and successful were the Nerf dart guns. And so I started redesigning Nerf dart guns, and I designed a whole product line, and they all had higher performance than the toy guns that Hasbro had at the time. And I presented that to them, and I tell people that I think I don't know for sure because they didn't say this, but I think I intimidated them because it was such a successful line that they didn't want me to take that product line to a different company. And so they could present a challenge. And so they did a license. And I did handle that a little bit differently. I said, look, I want to have my own subcategory under Nerf. And you brand it, name it what you like, but anything you sell under that category, I want you to pay royalties on. And they said, fine, and you agreed to that. And sure enough, InStrike started, the sales started to dominate the Nerf line, and it became their number one brand and line under Nerf. And then sure enough, they started putting, and I expected that because they really did work a lot better. And so sure enough, they started putting other products under there that didn't use the patents. But when I called them on it, they said, well, they said I was misinterpreting the contract. So we ended up in a lawsuit. I won the lawsuit. Nerf InStrike, because InStrike line was number one selling line under Nerf, and between Nerf and the Super Soaker, I'd say 80% of the toy guns sold in the world at that time were based on my patent. So I achieved my goal of becoming king of all toy guns. I often think that maybe I should have just continued in the toy business and expanded and built a toy company and became successful independently. But I chose to challenge myself in a new area, which is energy, which is where I'm focused now. And it looks like we're going to have another victory here, a huge victory.
Look at that. If I was a betting man, I'm definitely not betting against you. That's for sure. Going even kind of back in dealing with NASA, and then, like you said, king of the toy gun, that arena, and now the energy, especially with electric vehicles. And I always tell people, because I end up working on a lot of EVs, electric vehicle inventions, and I tell people who kind of talk about the range and, hey, well, you only get a couple hundred miles with the charge. And I'm like, trust me, this just how this works. The technology, the battery technology specifically is going to get better. You're going to look up one day and you're going to get more range out of that electric vehicle than you're doing with your gasoline vehicle. That's kind of how it goes.
Yeah.
That's man. That's go ahead.
You're exactly right. We're pushing the technology, so we're doing our part.
No, for sure. No, and like I said, but I'm definitely been on you guys to kind of continue to break through. And hey, when we look up 5 years or so from now, that you guys are going to be at the forefront of that, leading the charge on kind of the battery technology with everything that you're doing so far with the company Johnson and research and development.
Well, that's the intent. There are companies out there who claim they had a solid state battery. They've gotten a lot of money, but they don't have the real solution. We're about to get the money.
And you guys have the real solution, which is not seem like you're not just talking the talk, but walking the walk
Yeah.
as well. I guess the final question that I'll get you up out of here on is, again, you seem like you've made a life, been able to make, as an inventor, this is your full-time job. And I, as a patent attorney, get people who come up to me all the time and say they have an ideal or they kind of have a product or whatever the case may be. Some people don't know if they should kind of go all the way with it or bring it out or go through the process. But for someone such as yourself, who again has over 100 patents and kind of really has made a career as being an inventor, a very lucrative career that is, what advice would you give to aspiring entrepreneurs who may have an idea, whether it's big or small, and but they don't know whether or not to kind of go through the process or come out with it, or just just keep it shelved and not do anything with it? What advice would you give to that person?
There are a couple of things, pointers. I would say number one is persevere. If you believe in your idea, and you have a vision for how it will be successful, you got to follow through and bring it to fruition. And you can't allow other people to discourage you because they can't see your vision. But at the same time, there are a lot of good ideas never come to fruition. And my strategy has been to work on multiple projects and not put all my eggs in one basket, because there are things that can go wrong that have nothing to do with you or your specific idea. The economy, for example. I mean, there's just things that are just can happen. We went through a really tough time during the housing crash. We went through a tough time during the dot-com bust. Those things had nothing to do with me and my company and what we were focused on doing, but the economy made it difficult to find investors and things like that. That had nothing to do with the goal that we had set for ourselves. Even now, when we look at renewable energy, and the Trump administration is deprioritizing renewable energy, and he's got this mantra, drill, baby, drill. As much as I disagree with that, that's outside of my control. I can vote, I can advocate, but in terms of the direction that the larger world takes, so there are things that you cannot anticipate. So you work multiple solutions, multiple problems, multiple ideas to put the odds in your favor, because that's just the way life is. But applying yourself, obviously. I once heard an expression, I think it's true. Every ambitious project will yield useful results. It may not necessarily be the full goal that you set, but you'll get something useful out of it.
No, I like that, and I definitely agree with everything that you just said, man. I appreciate, like I said, the time, and you've definitely given us a lot of jewels, a lot of nuggets based on your storied career, and it seems like it's I was just getting started in a way, even though you've kind of have a lot of success with regard to NASA, as well as the Super Soaker and that kind of toy gun industry, and kind of the things that you're doing with now with the batteries and solid state technology. It seems like you're kind of just getting started. So I'm not going to be surprised if that big breakthrough that happens with everything with batteries.
It has been quite a ride. I've enjoyed all the things and challenges. I didn't mention working as a first flight test engineer on the B-2 program from the Strategic Air Command. And back then it was a highly classified mission project. Aside from Galileo to Jupiter, I also worked on as a fall protection engineer on the Cassini mission to Saturn, and of course I mentioned the Voyager mission. So it's been I've had I think the other advice I would give your listeners, and now I'm going to have to leave here, is bring some business sense to the table. My professional career was large scale government projects, so business was new for me when I got into Super Soaker and started going out on my own. So it was a lot to learn, but again, that was a challenge in itself.
Yeah. Yeah.
So I'll leave you with that.
Okay. No, and I like that. Thanks again, Mr. Johnson. I myself have to go watch this one twice, just kind of everything that you kind of laid out and talked about. It's a lot of jewels in there. So I thank you again. And I would imagine that the audience, when it comes out, the listeners are going to have that same sentiment in terms of the value that you provided here today. So thanks again for some time here this afternoon. And hey, continue to dominate, which I know you will, and kind of make those big advancements.
Okay, well, good luck to you on your broadcast and continue to press forward.
Thank you. I definitely will. Have a good one.
All right, take care.